Welcome one and all to the Math Magic Show. In this one, friends, we're going to take a look at finding the value of that integral. It's an improper integral because the lower limit is 0, but the upper one is positive infinity. So you see, that makes it improper, that positive infinity. And then the integrand, remember, is this expression, so it's 1 over 1 plus x squared. Let's just graph this out so we can understand better what this is talking about. So at step number 2 here, take a look. This is the y-axis, and then this is the x-axis. And when we say the upper limit is positive infinity, it's like saying x is going towards positive infinity. And this nice curvy looking line that represents the graph of 1 over 1 plus x squared within the first quadrant. So what this integral is doing is saying find the area here, okay? As indicated by the slanted lines. So let's go on to step number 3. Step number 3, take a look. Relative to step number 1. You see, in step number 1, we have positive infinity. Now, that upper limit gets replaced with t, and then you write lim, short for limit, and then limit as t goes to positive infinity of the integral from 0 to t of 1 over 1 plus x squared. Just like this shows. Again, precisely because the upper limit is infinite, in other words, x is going towards positive infinity. Okay. Now, notice this is t and this is x, so we do that on purpose so we don't mix up variables. Like, you don't want to have x up here, because then if you plug that in, then you have the same variable here, and then also here. So we use this as a kind of dummy variable, essentially. Anyway, let's move on. That should be discussed in a separate video. For our purposes, this gets the job done. So it turns out that the antiderivative of 1 over 1 plus x squared is easily found. It's just the tangent inverse of x. And then the upper limit is t and the lower limit is 0. And then the limit as t goes to positive infinity is what we have at step 4. Now we can evaluate this. So it's going to be the limit as t goes to positive infinity of tangent inverse of t minus the limit as as t goes to positive infinity of tangent inverse of 0. So plug in upper and lower limits. Now let's try to understand the value of this part, the limit as t goes to positive infinity of this tangent inverse of t. So this is a graph at step 6 of the inverse tangent function, at least the part that is relevant, which is basically within the first quadrant right here. That's the relevant part. So look, this says t is going to positive infinity. So that's why I've written here t and then infinity. So t is sliding this way towards infinity. As that occurs, tangent inverse of t, which is this graph, you see the y-coordinates, they slide ever closer to pi over 2, which is this horizontal asymptote up here for the inverse tangent function. So in other words, the limit as t goes to positive infinity of tangent inverse of t is just pi over 2 at step 7, you see? Now look at this next part. Minus the limit as t goes to positive infinity of tangent inverse of 0. Well, tangent inverse of 0, that's right here. Tangent inverse of 0 is 0, you see? Because when 0 goes in, 0 comes out. So this is the 0 that comes out right here. So that means, in other words, that this becomes the limit as t goes to positive infinity of just 0, because tangent inverse of 0 is 0 at step 7. Okay, right next to my little buddy there. So now take a look, friends. The pi over 2 is already found. That's it, so you copy it. And then the limit as t goes to positive infinity of 0 is 0. It's a constant. So lastly, therefore, the answer is pi over 2. This pi over 2 just represents the area between the graph, the x-axis, and the y-axis, even though the graph here, as you can see, represents the fact that we are integrating from 0 to positive infinity. It's an improper integral. Nevertheless, the answer is a finite value, pi over 2. One of the mysteries of calculus, right? That's really it. So leave a like, do subscribe, please share this with other people, leave some comments down below and suggestions for future videos. I love those. And now we'll see you in the next one.